Right now, somewhere in your phone, one small symbol is doing more work than almost any other symbol humans have ever made. You see it everywhere. You barely notice it. It sits in your bank balance, your GPS, your password, your clock. It is the least valued symbol in math. And it almost didn't exist. Not because no one thought of nothing. Everyone has thought of nothing. The real problem is stranger than that. Why did it take humans thousands of years to write nothing down? Ancient Babylonians counted in the thousands. Egyptians built pyramids with exact geometry. Greeks mapped the stars and measured the size of the earth. But none of them gave nothing its own number. They left a gap instead, a blank space, a mark that meant there's nothing here, but it never acted like a real number. You couldn't add it. You couldn't subtract it. For most of human history, zero was a hole in the page, not a number. Then, around 500 CE, in the city of Kusumapura, an Indian astronomer named Aryabhata sat down to calculate the positions of planets. He needed a system precise enough to track huge numbers with many decimal places. So he used the word ka, which means empty space, the same word used for the sky, empty. He placed it inside his number system, the way you might leave an empty chair at a table, marking a spot even when no one sits there. This wasn't zero yet, not the way you know it. It was zero's shadow, a symbol for absence, not something you could calculate with. But shadows have a way of becoming real. A century later, a sharp and famously arrogant mathematician named Brahmagupta did something almost no one had dared to do. He picked up that placeholder and asked a question. What if nothing could act like something? What if zero wasn't just a gap, but a real number? In 628 CE, in a text called the Brahmasfuta Siddhanta, Brahmagupta wrote down the rules. A number plus zero stays the same. A number minus zero stays the same. Zero plus zero is zero. These feel obvious to you now. You learned them before you could tie your shoes. But no one on earth had written them down as formal math before. Brahmagupta wasn't just naming an absence anymore. He was giving zero a place at the same table as 1, 2, and 10,000. Then he tried to give zero one more power. Division. He said that a number divided by zero equals zero. Say that out loud and it sounds almost careless. It's also completely wrong. And Brahmagupta seemed to sense that something was off. But he published the rule anyway, admitting, I don't know, wasn't something a royal mathematician could easily afford. For 500 years, that broken rule sat inside Indian math like a splinter. Scholars copied it, taught it, passed it on. It traveled with traders along the Silk Road. It slipped into Persian translations. It reached Baghdad's House of Wisdom, where Islamic scholars absorbed Indian numerals and this new idea of zero. The same system the world later mislabeled Arabic numerals, even though it began in India. But the division problem followed zero wherever it went. And zero may be even older than Brahmagupta. A birch bark manuscript found near the village of Bakshali, in what is now Pakistan, uses small dots as placeholders in its calculations. For years, historians guessed it was written in the 8th or 9th century, safely after Brahmagupta's time. Then in 2017, researchers at the University of Oxford ran radiocarbon dating on the bark itself. The results surprised everyone. Some parts of the manuscript dated back to the 3rd or 4th century, hundreds of years earlier than anyone expected. If that dating is correct, the dot that became zero existed in India long before Aryabhata ever sat down at his observatory. It had been quietly waiting in temple records and trade notebooks, long before anyone gave it formal rules. Wait, if you're finding this fascinating, give this video a like and subscribe to the channel. Let's continue. Here's the part most people never learn. Zero almost broke math before it built it. If a number divided by zero really equals zero, you can use simple algebra to prove that 1 equals 2. Try it. The whole system collapses. Other mathematicians noticed this within decades, and people's trust in zero started to wobble. Some avoided using it for division altogether. Others tried to patch the rule. It wasn't until the 12th century, when a mathematician named Bhaskara II tackled the problem directly, that someone got closer to the truth. Dividing by zero doesn't give you zero. It gives you something infinite. something you can sense but never fully hold. Bhaskara called this result kaheda. He described it almost like a wound that never closes. What he was circling is what you now call infinity, and the fact that he was wrestling with it through pure logic, centuries before calculus existed, shows just how far ahead of its time this idea really was. A wrong rule about division might sound small, but math doesn't forgive small mistakes. One contradiction can crumple everything built on top of it. If Brahmagupta's error had gone unanswered, the entire system of place value math risked being seen as untrustworthy. The mathematicians who came after him weren't just adding new ideas, they were rescuing one that had almost collapsed. So what did zero nearly cost ancient India? Not money, not war. Something quiet, trust. An idea that contradicts itself doesn't survive long. It gets buried. Zero could have been dismissed the way so many flawed ideas in history were dismissed, treated as a cunning trick that simply didn't work. Instead, generation after generation of Indian mathematicians stayed with the problem. They didn't dismiss zero because it was hard. They kept fixing it because they sensed it mattered. The concept of zero wasn't an overnight revelation by a single genius. It was argued over, doubted, broken, and rebuilt for centuries before it became the symbol you see everywhere today. From there, zero crossed into Europe through trade and translated texts, slowly replacing Roman numerals, which had no zero and made arithmetic painfully hard. Try long division in 1994. Indian zero didn't just make math simpler, it made modern science, engineering, and computing possible. Because every digital system you use is, underneath it all, a conversation between 1 and 0. Some cities in medieval Italy even banned these new numerals from official records, worried that a symbol for nothing could be used to forge numbers or hide fraud. The same zero that once nearly broke Indian math was now seen, centuries later, as a threat to honesty itself in Europe. But it survived that suspicion too, the same way it survived its own contradictions until it became invisible, woven into every system you now trust without question. You don't think about any of this when your phone battery hits 0%, or your bank app shows a zero balance, or a countdown clock ticks towards zero before a launch. You experience zero as emptiness, as the number that means nothing is there. But it took a civilization's centuries of mistakes, contradiction, and persistence to convince the world that nothing was actually something worth counting. So next time you see that small, round, empty symbol, look at it a little differently. It isn't empty at all. It's the loudest silence in the history of math. And it almost didn't survive its own birth.